Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Batrisha Miti Effendi and we are from Group 9. My group mate is Muhammad Nazmi Benjamin, Pavitran anak lelaki Rajendran and Wan Azmina binti Wanaman. For the theory and the background for our project, bawah lagi. Ini. A synchronous counter is a one whose output bits change state simultaneously with no ripple. In these types of counters, the flip-flops are clocked at the same time by a common clock pulse. Thus, all the flip-flops change state simultaneously in parallel. It advances upward in sequence like 0 until 7. The counter advances to the next output state on the positive edge of the input clock. The outputs of the counters may be preset to a high or low level. A low level at the parallel enable inputs disables the counting action and causes the data at the data inputs to be loaded into the counter on the positive edge of the clock. A low level at the master reset input sets all the four outputs of the flip-flops to a low level after the next positive going transition on the clock input. The synchronous reset features enables the designer to modify the maximum count with only one external NAND gate. And for the procedure at the part 1, firstly, we have to open the new project, and then we must enter the file name and go to location to choose assign save. And after that, we find the button next, and then we choose the button finish down there. And after that, we click at the new source to build up the coding. And after that, we choose the Verilog module, then put the student name at the file. And after done, we click next. And after we finish, output is stated and we have to insert the coding and we can start the programming. And this is the result for part 1. This is the coding. And after that, we get the test bench for the input. And this is the schematic part 1. There are two parts for the schematic part 1. And this is the output for the part 1. And the procedure for part 2 is stated over there. And the schematic is, we got the main part. And the schematic part 2 also, we got the two part over there. And this is the result for the test bench. This is the output for the test bench.
Assalamualaikum, my name is Wan Azmina binti Wanaman. This is the block diagram for part 1 and part 2. We got from the coding in part 1 and part 2. Block diagram part 1 is designed based on multiplier 6x6. The input is X and Y and the output is P. Block diagram part 2 is synchronous digital system. The input is ID, clock and X and the output is Z. In this conclusion, the objective of this experiment were effectively presented by testing half adder circuit and full adder circuits, half subtractor and full subtractor circuits, and obtaining the truth table for each circuit state above. An adder is a device that can add two binary digits. It is a type of digital circuit that performs the operation of addition of two numbers. It is mainly designed for the addition of binary number, but they can be used in various other applications. There are two types of adder. One is half adder and another one is known as full adder. The half adder adds two binary digits called as using an addend and produce two outputs as sum and carry. SOR is applied to both input, top procedure sum, and gate is applied. Lastly, we learn how to set up and perform simulation and verification of a moderate complexity digital system design using Xilinx Vivado or Xilinx ISE FPGA design tool. We continue for part 1. Pavitra will explain for part 1 and Nazmi will explain for part 2.
For the part 1, we are going to do open the file ISE design suite 14.7. The intro of the file will be like this. We have to do select file, then we have to choose new project. After that, we have to set here name of project, like save our name. Here you have to choose the file for to save the location. Once you save, you have to proceed next, then next, and then you have to press finish. And then after that, you go here and then you right click and you got a new source. After that, you have to press verilog module, then put the file of the name. Then yeah, the location of the file, then press next, next, then after that finish. Yeah, this is the full view of the do coding. The module is the starting point of the coding, then module is the ending of the module coding. The between is we have to put the coding. So by the way, we have already do the coding ready. Just we into the how to do the open the new project. Let's we go for the coding. Here the coding. First of all, we have to do part 1. The part 1 is we have to do the of header coding. Of header coding, sum count AB. Input here AB, output is sum and count x1 and 1 sum AB and 2 count AB, and then after that end module. This is for the of header. For that we have to press that we have to check the coding. It got complete successfully. After that we have to do multiply 6 by 6. If you want to do multiply 6 by 6, you have to do up header and then full header. Just only you can do it multiply 6 by 6. This is the coding. I just remove from the notes given by Mr. Professor Masrul. This is the coding. They got lot coding. Then after that, hang module. Then rerun all. Complete was successfully. After this, you have to do the coding of the test bench for the part 1 to get the output. This is the coding for the test bench. The test bench underscore multiply 6 by 6. This is the coding what we are put on the screen. That's the coding. We have to rerun all. It's a complete all successfully. And then after that, we have to do check the output. The right click, you have to run. It's a complete. The coding was complete successfully. They got the output of the part 1. The POP11. This is the output for the 11 count. The AB. This is the output. Yeah. Once you done the output, you have to do check. Okay. to do save file or like that, then just this is the part 1 from me. Then the other part 2, the part 2 will continue by Nazmi.
So for the part 2, we continue with using Xilinx. Okay, still the ISC project navigator. You open for the new project, and then you choose file name, and then next and finish, and then we can see this interface, and then we put the coding. This is the coding module counter. So use the coding, and then we combine with the main part. So then we synthesize txt. We click for rerun all, and then we wait for the result. Okay, successfully, and then we view RTX schematic. We choose start with schematic of the top level block, and then OK. So this is block diagram. So we can see the 40 bits, and then we click yes. We can see the output input for input 1, and then for the mode counter, so next we do the test bench. We add new source on the file, the first file, new source, and then we can see the interface for fill the coding, and then we put the coding inside the interface. Then we click the behavioral check syntax. Okay. We click rerun all. So the behavioral check syntax complete successfully, and then we simulate behavioral model. And then the result for the test bench is shown. So we can see when the password is right, then it will be can access like this. If you put the wrong password for your ID metric cards, it will trigger and trigger the alarm and cannot access this. Right. Okay. So that's all for the part 2. Thank you.